All right, so it's 6:30, so we're going to go ahead and get started. I'd just like to say good evening, everyone. Thank you for joining us here at the Hudson Library on today's gorgeous April evening. I am very pleased to introduce tonight's speaker, science writer Lisa Baril, who will be discussing her book, The Age of Melt: Why Glaciers, Ice Mummies, and Ancient Artifacts Teach Us About Climate, Culture, and a Future Without Ice. Before we begin, just note that copies of Lisa's book are available for purchase, courtesy of the Learned Owl. So that will be available for purchase and signing during our author reception at the end of tonight's event. And also, just a little announcement for the library. Next month we will be celebrating the history, art, culture, and archaeology of Turkey during our Tour with Turkey Month. So because this is a bit of an archaeology program tonight, I want to give you a heads up that we're going to have numerous virtual archaeological tours next month, as well as an in-person author event to discuss Alexander the Great. So please check our website for more information about all of those events. So now I'd like to introduce tonight's speaker. Lisa Baril is a science writer who has written about natural resources and science for national parks across the southwestern United States. She holds a master's degree from Montana State University and is a member of the National Association of Science Writers, the Society of Environmental Journalists, and the Outdoor Writers Association of America. Please join me in welcoming Lisa.
I've only been to Ohio one other time, and that was to do the biggest week of birding. Has anybody ever done that? It's so fun. You gotta go if you haven't done it. It's just really amazing. All of these migratory birds are coming back from their wintering grounds in Mexico and Central and South America, and when they hit the lake, they just need to take some time to recuperate before they cross the lake. And so you get to see birds really up close that you normally wouldn't get to. And I say that because I'm an ornithologist by training. I started my career as a wildlife biologist, studying birds all over the place, really, and internationally as well. And then in about 2005, I landed in Yellowstone National Park, where I still live today. I worked for the Yellowstone Bird Program for a number of years. And, but my husband still works in the park, so lucky me, I still get to live there. It's a wonderful place, so I should come visit that as well. So anyway, yeah, it's really wonderful to be in your beautiful city. As I was coming downtown tonight, I was just admiring all the gorgeous buildings and passed by the bookstore, and I was really excited that it's called the Learned Owl. That feels like really special to me. Anything to do with birds, so So as an ornithologist, it might seem like a really strange turn to write a book about archaeology. Like, how do you do that? Why? But I've always been interested in the relationship between animals and the environment. And in particular birds in the environment, and how the environment shapes animals. And humans are really another species on the planet. We are. And so I like to think about us in that way, as another species on the planet that is influenced by the environment as much as we are now influencing the environment. And so that's one of the things that really drew me to ice patch archaeology. We'll get into what that means in a little bit. And it's also multidisciplinary. Like, I like the combination of climate change, of archaeology, of the study of our past, and it really brings all of these different facets together that really, really intrigued me. And so when I read about artifacts that were melting out of ice patches high in mountain ranges around the world, I had to learn more. And because I'm a nerd, I set a Google Scholar search for anything related to ice patch archaeology, and lo and behold, it seemed like every day there was another article about something else melting out of the ice somewhere. You know, a lot comes from Norway, but other parts of the world as well. So, this a little bit. So, you know, we're fascinated, I think, by archaeology in terms of, like, think of it in terms of lost cities buried beneath jungles and buried treasure on some tropical island, or ancient relics that might hold some magical power. But what a lot of what archaeologists do is much more mundane than that. And I apologize if you're an archaeologist, but you might agree with me that a lot of what archaeologists are looking at is pottery shards and bone fragments and bits of charcoal. And from these small bits and pieces of our past, they are able to put together stories of what life was like, long ago when we didn't have written records. But ice patch archaeology is kind of a different offshoot, a new branch of archaeology. And so, most people, when they think of archaeology, as I said, think of these buried treasures, and Indiana Jones. So, which is to say that most of us don't really know that much about archaeology to begin with, and including myself before I started researching it. So rarely do archaeologists find or discover something in any discipline, really, that changes the way we think about the world, the way that we think about our place in it. And I'll just give you a couple of examples. That is not what I meant to do. That is a beautiful picture, but there we go. Okay. So this is a photograph of Ultimire Cave in northern Spain. It was discovered by a couple of children who were goofing around, as children do, and it was the late 1800s. And they had found this cave with all of this gorgeous cave art. And it turns out that this cave art was from the Paleolithic, so some 37,000 years ago. People were painting using the materials that they found around them, painting the things that they saw around them. Pleistocene animals that no longer existed in Europe. And it really revolutionized the way archaeologists thought about our place in the world. They thought humans were just eking out a living, trying to survive in the Pleistocene, in the Paleolithic period, when really nothing could be further from the truth. They were thriving. And part of that includes making art. And so, there's a lot of talk about whether this art is just for art's sake, or art with more meaning than it, and I think it has to have some more meaning. And I think archaeologists have been discovering that now, that a lot of these paintings are actually talking about showing them the life cycles of animals, when to hunt them, when would be a good time to hunt them, where they go, migration patterns, when they're having young. So there's a lot of information in this. Maybe they weren't writing, but they were conveying a lot of information about the world around them, and then leaving that information for others to find. So I think that's, oops, I keep doing this. I'll get it right. Okay, here we go. I'm just going to keep it on this button here. Machu Picchu is another one in Peru. Before this was discovered around 1911, archaeologists really didn't think people could, pyramids and stuff, but people didn't think, that South American cultures really were that evolved to build some structures that were, as amazing and complex as these societies were. And they were wrong. And then closer to home, sort of, is the footprints that were discovered in White Sands National Park back in 2020. And some archaeologists had discovered these footprints, and they show maybe a teenage girl or boy and a child, and they were able to tell from looking at these footprints the pattern of this young teenager walking and occasionally picking up the child, because there would be little footprints next to her, and then she would pick up the child, and the hip that she had the child on, that foot was pressed down a little more, and then she'd shift to the other side, and they could tell that, and they could read that story, which is really incredible. So what's even more incredible is that they found seeds embedded in these footprints, in the layers of footprints, and they were able to radiocarbon date them and get really precise ages for how long ago someone might have made these footprints, and those dates came back 20 to 23,000 years ago. And archaeologists prior to that had not assumed through science, they had only thought that people entered North America some 13,000 to 16,000 years ago. Indigenous people will tell you that they've been here since time immemorial, and so I think the truth is somewhere in the middle there. But every time one of these discoveries occurs, it kind of shifts our understanding of our place in the world and just who we are. And so Ice Patch archaeology got its start with a very similar kind of amazing discovery that has shifted the way we think about ourselves. And that discovery was the discovery of a 5,300-year-old mummy by the name of Ötzi. And he was discovered in the Ötztal Alps. The Ötztal Alps are a gorgeous mountain range that span the border. They form the border between Italy and Austria. And he was discovered by a pair of hikers, Helmut and Erica Simon. And you can see them pictured up here to the right, and I just love their little matching outfits. But they had, this was 1991, they had visited the same area 10 years earlier and loved it so much they wanted to go back. And I had the opportunity to visit too, and I thought, this is amazing, I can see why they wanted to come back. And they were hiking in this rugged landscape. These are the Alps that they were hiking in. And they were off trail, and they were climbing an 11,500-foot peak. And as they were coming down this afternoon, they were looking for the trail. Because at this elevation, there aren't really many markers or things to kind of keep you on a path. There's no real path. And so they were looking for cairns, these like rock piles that are made in the wilderness so that people can find their way where you can't put markers on trees and such. And they thought they saw one. And so they started walking towards it. And as they got closer, they realized that they weren't looking at a trail marker. They were in fact looking at a human body. And so just warning here, this is an image of a deceased person, Ötzi. So this is the first photograph that was ever taken of Ötzi. And it was one of the last on their roll of film, because this was back in the days of film. They had maybe a couple left in there, I don't know. I remember those, when you just don't know if you're at the end yet. So they were almost at the end. I think they might have had one or two more photographs left. But they snapped this photo, and you can imagine how creeped out they were, for lack of a better word. I would have been finding a person, and to them he looked very well preserved, like he had died not that long ago, and they had no reason to think that he was an older, someone and some great discovery. That summer alone had been a very warm summer, so the glaciers and ice were really melting. And 5 other bodies were found melting out of glaciers just that summer alone in this mountain range alone. Mountains are very dangerous places. They're wonderful to visit, but you have to be careful, and you have to take care when you're traveling in high elevations, because winter could come at any time. I have been snowed on in August in mountains. And so, people die all the time in mountains, just a simple twist of an ankle, and you haven't told someone where you were going, or hypothermia. So they, when they told the rescuers and recovery team, because I think it's obvious that nobody was going to rescue this guy, they told the recovery team, about him, and they came up to get him, and they also thought, well, this is just another one of these bodies that had melted out. He must be relatively new. And so he was packed into a black body bag and taken down to the undertaker at the local university in Austria. And the undertaker is looking at his body, and he is seeing some unusual things. Like, he had been wearing these leather trousers. They were really ripped up, but it's really unusual for someone to be wearing leather trousers in the mountains these days, right? And he had also been wearing a leather shoe that was stuck with grass. That's unusual as well. And the recovery team had gathered all of these belongings, what they assumed were belongings of this man, from the area, and brought them down with him. So he was looking at some of these objects, and these are them. You can see the shoe over here on the left-hand side, a little knife, a dagger, with like a rope sheath, a bearskin cap. And so these things really alerted him. This isn't a case for a undertaker, it's a case for an archaeologist. So luckily there was one local at the university, called him up, and they had no reason to know each other. Their paths had never crossed before. And he came and took one look at the body and kind of didn't really pay too much attention to it, because archaeologists are really interested in the objects that we have left behind. And through those objects, they can kind of guesstimate when they came from. And so he was looking at how it was made, the types of tools, everything about it to kind of estimate, when had this person been alive. And he estimated at the time about 4,300 years ago. Well, when they got the radiocarbon dating back, of course, it was much older than that, 5,300 years old. And it was a huge sensation. People were calling this archaeologist at all hours of the night to get his comment, and actually it was leaked to the press, and he was called in the middle of the night to ask, what did you think about this guy getting found, from 5,300 years ago. So he was found, he was from an age called the Neolithic, which is, I feel like this is, okay. He came from an age called the Neolithic, which is the start of farming societies. And in Europe, those farming societies arrived around 6,000 years ago and made it up to the Alpine foothills. So he was kind of like at the edge of the Neolithic, right before the Metal Ages and the Bronze Age, Copper Age, and things like that. So they began wondering, how had he been preserved for so long at such high elevations in the mountains for the last 5,300 years? Because in order to have been preserved, there must have been something about him that made this possible. Well, and it turns out that he was so well preserved because he'd been encased in ice, and ice is an excellent preservative. So I don't know if you're anything like me, I have things in my freezer that are mysterious and unlabeled, and I just sort of leave them there because they're not doing any harm. And as long as my freezer doesn't break down, all those little microorganisms that would normally come and make things gross are held at bay. And it's the same thing with Ötzi. He was encased in ice for about 5,300 years. And because of that, microorganisms and things that would normally break all of that organic material down, that once living matter down, were kept at bay. And that is how he was preserved. So prior to his discovery, no one really knew that ice in the mountains could preserve these ancient things from the past. So organic artifacts are made from once living materials like branches, plant fibers, animal sinew, which is the tendons and ligaments. It's really good for sewing material. Bird feathers, these were the things that were available to people at that time. But because they decay so rapidly, archaeologists really rarely get to study them. And so this was kind of a boon. But it's a paradox, right? Because as soon as the ice melts, these artifacts are exposed and they begin to decay. And it's only a matter of time before they become dust. And it's these pieces of human history that are disintegrating as the climate continues to warm. So ice patch archaeology has come about directly out of our climate crisis, which I think I don't know of any other discipline other than the study of climate change itself that has given rise to a whole other branch of, not a whole other branch of science, but an offshoot of archaeology. It's really pretty amazing. But not all ice is equally good at preserving artifacts. So, in the mountains, when we think of ice, we think of mountain glaciers. Mountain glaciers are the sexy type of ice. Ice patches, not so much. And before Ötzi, nobody gave those ice patches all that much attention. So this is an example of what a glacier looks like, and this is an example of what an ice patch looks like. And there's some very fundamental differences in why one is better at preserving artifacts than the other. So glaciers, if you think of them being in mountains, they accumulate snow up high, and a lot of that snow and ice gets compressed, and under the weight of all of that ice and snow, it begins flowing down the mountain like a conveyor belt. And as it flows down the mountain during the summers, at the foot of the glacier, some of that ice and snow will melt. And this constant motion of a glacier means that anything that falls on top or within it is crushed, because ice is really hard. It's hard as a rock. It's like a type, they do consider it, like scientists, a type of rock. It's so hard. And so something like Ötzi would have never stood a chance being preserved in a glacier. The other thing about glaciers that make them not so great at preserving artifacts is that the ice within them isn't very old. So when we think about this conveyor belt of ice, it's being constantly renewed. It's accumulating up high, it's melting down low, and this means that even though a glacier may have been in the same spot for thousands of years, the ice within it is only about 500 years old or so. So nothing much older than that could be preserved in a glacier. Ice patches, on the other hand, never grow large enough to begin flowing. They are usually located on shallower slopes on the lee side of mountains. A lot of the accumulation that they get is from wind-driven snow events that deposits snow on top of them rather than direct snowfall, unlike glaciers. And because they never get large enough to move, they anything that happens to land on them or gets embedded within it stays preserved in almost its natural state, as though it was dropped yesterday. And I had talked to some archaeologists who were just amazed. They had found some arrows and different objects that they just couldn't believe looked as good as they did, and they were thousands of years old. Some of them have bird feather fletching still attached with sinew on these arrows, and they've been able to identify the birds that it came from, which is cool. And so some of these feathers would seem to be more decorative than functional, like northern flicker. If you guys are familiar with the flicker, probably not. The feathers that they had been using were not those that would have lent well to, an arrow being very aerodynamic. So anyway, more research needed on that. So, for a really long time, archaeologists really had overlooked ice patches because, one, they didn't think that they were all that old or that interesting. But more than that, archaeologists really had long believed that people didn't frequent the mountains very often. I mean, of course, they knew that people would go into the mountains for hunting as they were following the green wave, and the animals would follow the green wave as it crept up the mountains and hunt animals and look for other sorts of things, berries and plants. But they weren't really, they were more concerned with the river valley bottoms and these, kind of the bigger, sexier archaeological sites. They hadn't found that much in mountain landscapes. Mountains are really harsh on things, even inorganic objects. They're really, the soils are really thin in mountains. They're highly erodible. The climate is difficult. So other than a few like cave dwelling type things, shelters with the little bits of charcoal and bone fragments, not too much had been found of interest in the mountains until Ötzi. So ice has really been long in the realm of glaciologists, and for a really good reason. Scientists can learn just a ton about Earth's history through the ice. They can use it as a gauge for current climate change, and they can tell what the climate was like in the past. So glaciers are super cool in that they trap tiny bubbles of air from the past atmosphere. And scientists have learned, and they grow like trees do, like with rings, like layer upon layer. And so they can date those layers over time. And they've also learned how to date the ice itself. And they can extract those air bubbles, those tiny air bubbles, and determine what the climate was like in the past, many thousands of years ago. And so most of this work, this climate work, comes from the polar regions. And this data is from an ice core data collected from the polar regions, and it gives a history of the last 800,000 years. I just said that glaciers only preserve ice that's no more than 500 years old. But these are ice sheets, which is a type of glacier found at the poles. And because it's a much flatter landscape, it's cold all the time, all year round. They're just constantly accumulating ice rather than melting it. Of course, there's some melting always going on. And because that landscape is super flat, they're flowing, but they're spreading out a bit more slowly. So they've been able to extract ice up to 800,000 years old. And from that ice, they have, I want to say, incidentally, just recently, a team in Antarctica has extracted an ice core over 5 years. That is, and I need to check my numbers here, it is 1.2 million years old. It's the oldest ice in the world. And that core of ice came down in pieces. But if you were to string it all together, it would be almost 2 miles long worth of ice. And so over the next decades, we're going to be seeing a lot more signs in the last 2 million years with this ice core data and telling us what was going on in the past. So we know the climate is warming because over the last 800,000 years, it has shifted from around 170 carbon dioxide. So this is a carbon dioxide over time, over the last 800,000 years. You know that carbon dioxide is a climate warmer. It's a greenhouse gas. So when carbon dioxide is low, we are in an ice age. It's cold. When carbon dioxide is high, we're in a warm period. And over the past, climate has shifted quite a lot. There have been warm periods, there have been cold periods, but largely it's really fluctuated within this range of about 170 to about 330 parts per million. Anatomically modern humans, that is someone who would recognize as you kid walking down the street, right, Main Street, right out here, arose sometime 350,000 years ago. That is the oldest anatomically modern fossil ever found in Tanzania in 2018. But some scientists think our species might go back to 500,000 years old. But you never know if you found the oldest of something, right? So they're still looking. But our genus, Homo, first emerged around 2 million years ago. So during our entire history of being humans, we have been living in an ice age. We're living in an ice age right now. It just happens to be a warm period within an ice age. So we are uniquely adapted to living in cold environments. We are much more able to adapt to cold environments than we are to warm environments. Humans really can't tolerate the heat very well. And so what we see here is that sometime around 1970 is that glaciers really started to show the significant measurable melt. People have been monitoring glaciers, especially in Europe, since the 1600s. There are lots of historical archives of glaciers and paintings, and not just exact measurements, but they're using some of this historical data to kind of inform how glaciers have been changing over time. And so really in 1970 we started seeing glaciers are melting. Most of them are melting around the world. So last year, carbon dioxide was 423 parts per million, which is 52% the pre-industrial levels of about 280. The last time carbon dioxide was this high was about 3 million years ago. That was before our genus, or way before our species emerged. It was called the mid-Pliocene warm period. And temperatures during that time were about 3.6 to 5.5 degrees warmer than they are today. Sea levels were 50 to 80 feet higher, so the Earth just looked really different, and we did not exist. So that's something to think about. So given the current levels of carbon dioxide that we put in the atmosphere right now, half of all mountain glaciers are expected to disappear in the next 75 years. And this is already baked in. There's really not much we can do about that. Those glaciers are responding to the warming that we've already put in the atmosphere. There's a bit of a lag between when glaciers melt and when we have put the carbon dioxide into the atmosphere. So if we continue down our current path, we're headed for about a 5-degree increase in temperature by 2100. And we can see this with our own eyes. At this level of warming, all the glaciers in the Alps are expected to disappear. So this is the famous Mer de Glace in Chamonix, France. And you can see that, yeah, there's still a glacier in this valley here, but on this left side of the figure, the glacial ice goes way up the sides of the mountain. And on this right-hand side of the figure, you can see that it's much skinnier. So not only are glaciers melting and they're receding up the mountain, but they're melting from the top down as well. So they're losing a lot of volume of ice and depth of ice. We are expected to lose all of the glaciers in the Rockies, or in New Zealand. This is Franz Josef Glacier, and you can see a couple of people there for a little bit of scale here, how much ice has actually been lost. Still a lot of ice there, but man, imagine if it was still like that. And then this is close to my heart because I live just at the opposite end of the state, but near Glacier National Park. And I take a trip there, try to, every year with my friends, and we visit the Grinnell and Salamander glaciers regularly. And we just, can't believe it. I mean, I wasn't alive in 1938, but, the Glacier National Park is this amazing archive of photographs of all of the glaciers, and they're continuing to take photographs to show how much they have melted. There used to not be a lake there. There is now. I have a friend that will go swimming in it. I do not do that. So you can't really talk about ice patch archaeology without talking about climate change. So I mentioned a few minutes ago that ice patch archaeology arose really out of our climate crisis. And if glaciers are melting, obviously so are ice patches. So, not long after Ötzi, other artifacts began to come to light in other places around the world. And where? All over is the short answer. Wherever archaeologists are looking, they are finding fragments of our history melting out of the ice. And most areas with ice patch artifacts were first discovered by recreationists like the Simons, just people recreating in the mountains. So over the last 30 years or so, most of that work has taken place in the northern hemisphere, which makes sense if you look at where all the ice is in the world. And in these mid-latitude mountain ranges like the Alps, like North American Rockies, like New Zealand Alps, because those are the places that are losing the ice the fastest. And also, that's where a lot of the ice patches are. And this really begs the question of, what were all these people doing in the mountains? What was Ötzi doing in the mountains? Were they seeking out ice intentionally, or were they encountering it by chance? How did their belongings get entombed in ice in the first place? So to answer that question, let's travel to Norway. So in the early 2000s, there was an amateur archaeologist, Jan Stokstad, who found some interesting objects at the edge of an ice patch near Jotunheimen National Park, which is the land of the frost giants, very appropriate. And this is in south central Norway. He found bundles of sticks with pieces of wood or even fabric attached to one end. He found a few collapsed stone structures, and this is really a little bit washed out, but in the center of the frame here you can see kind of a built-up rock. Glaciers don't do that. Someone had put these rocks there and made a stone blind out of it. And he also found arrows like this one. And so later, when archaeologists returned to do a thorough survey of the site, they found hundreds of those strange sticks, and more hunting blinds and many more arrows. And so they started to put together the story. What were those sticks? What was going on at this ice patch that made it such a place for people to congregate and hang out? Well, it turns out that reindeer, they're called reindeer in Scandinavia, but caribou in North America, which were and still are an important subsistence species, use ice patches during the summer months to cool off and escape biting insects. So if you've ever been to Alaska or anywhere, north in the Arctic Circle, it's horrendous in the summertime. And these animals live there full time. They can't, use bug spray or get inside or put on a bug net. And so they've adapted to kind of avoid getting bitten by bot flies, mosquitoes. And these bot flies are really irritating. They lay eggs in their skin, up their noses, and it's just, I can imagine it must be really uncomfortable. And so they head out to these ice patches to not only stay cool, but also to avoid these insects, because insects don't really do well in the cold. And as we know, summer comes around and we're getting eaten alive. And so hunters knew this, and they used that to their advantage. So they use these wooden poles as drive lines. So remember that they are well above tree line. Let's go back. There's nothing up there except for ice and rock, granite. And so reindeer are really not used to seeing things flapping in the wind above, there's no trees or grass, and it freaks them out. And so if they put these drive lines in, they can kind of herd the reindeer towards hunters that are waiting behind stone blinds with arrows, and then they would harvest them. And so it was a community event. They found bundles of these sticks that they had stashed there, and they would leave them up there for years. They would come back every year and then set up these drive lines again. So the same sort of phenomenon is happening in the Yukon in Canada, and this is a figure that kind of depicts how hunters would have hunted this. So the caribou approach from below, and they hang out on these ice patches, and in the afternoon, the prevailing winds are heading up the mountain. And so in order to avoid being scented by these caribou, the hunters would go up above and then shoot them from above. In the Absaroka Mountains near where I live, near Yellowstone National Park and Wyoming, the same sort of phenomenon is happening there. They have found stone blinds there and all sorts of interesting objects. And there are no caribou here though, right? And so caribou were in a little bit of Idaho and some parts of Montana at some point in the near past. In Idaho, just up to a few years ago, there were still caribou there. There aren't anymore, and there never were. So what were they hunting? People were hunting bison, deer, elk, bighorn sheep that would live in these mountains. So one scientist I spoke to, this is a photograph of archaeologist Craig Lee, who's from Bozeman, Montana, works at the university there as an archaeologist, as an ice patch archaeologist. And one day he was walking along the edge of an ice patch, and he'd been doing all of these surveys for many years and was just not really having that much luck, not like the Norway guys were, not like the folks in Yukon. I think he was feeling a little upset about that. And he saw this stick emerging from the snow, and he picked it up, and his whole body, as he told me, began to quiver and shake. Now you or I would look at something like that and think, well, it's just a broken stick, right? And he was like, this is an incredible find. And it turns out that this is the foreshaft of an ancient hunting weapon called an atlatl. Atlatls came after the spear, but before the bow and arrow. And so if you think of a spear, you are just throwing it with your arm, and all you have for leverage is your arm. So, you're only gonna get it so far and so fast. The atlatl, on the other hand, uses what's called a throwing board. And so there's a flat piece of wood with a notch in the end that you put your spear into, and it increases the leverage. It's like a third arm, think of it. And so if you pull that back, this illustration here, if you pull that back and throw it, it goes much farther and much faster than a spear would alone, using just your arm alone would. And if you're hunting bison and other animals, or bears even, you don't want to get too close because you might get hurt. So the more distance you can put between yourself and the animal, the better. So when he sent a little bit of the wood off to get radiocarbon dated, it came back as 10,300 years old. So it's right at the end of the last ice age, which is really amazing. It is the oldest artifact to ever have been found from an ice patch. And it was found in 2007, I believe, and it's still the oldest ice patch artifact to this day, which is really remarkable. And that's kind of what got me hooked on studying ice patch archaeology, is that it's close to where I lived. I had been to this ice patch that he found this in. It's not that far from the road, and it's really just like surreal to me that to think about someone that was hunting using this tool 10,000 years ago. What's even more remarkable is that he found these crosshatch marks on it that he believes indicate ownership. So you are looking at these pieces of wood, and it took a lot to make something like that. It was a real skill to make it. It took a long time to cure the wood and to harvest it and to carve it, and so he cared for it and expected to get his weapon back, but obviously he lost it at some point. So far, that ice patch is still in existence, and they have not found a body. But who knows? Maybe that'd be cool. So, when scientists were asked what Ötzi had been doing at more than 10,000 feet, 5,300 years ago, the archaeologist in charge of Ötzi and studying him said, well, maybe he wanted to visit his girlfriend in the next valley. And it turns out that was not the reason why, and I won't spoil it for you, but the real story is much more interesting than that. But what Spindler was really getting at was that perhaps mountain passes were used as travel routes for people going from one valley to the other. If you think about the Alps, they are made up of many, many mountain chains, kind of strung together, and it would be ridiculous to go around them. And it only takes a few hours to go up and over using a mountain pass. And so that's what people did. And so they determined that travel was probably the primary mode of using these ice patches, or not even using these ice patches. They were encountering them by chance, because if you're traveling, you're just like going up and over, and maybe you're taking a break, maybe you're getting a little bit of water, some fresh water from the melting of these ice patches, maybe you're just cooling off or hanging out, and people would lose things, and it turns out they lost a lot of things. Shoes, a lot of shoes, a whole assemblage from mercenary, 15th century mercenary, tons of Roman coins, lots of hobnails, which were used to hold the shoes to the uppers together, and this pin down here, this Bronze Age pin. And they even found a shoe repair kit, which I think is really funny, because along with the hobnails, it just means that people's shoes were falling apart all the time. And it's amazing because these artifacts span 9,000 years of history. So it's a lot, but it's all of these kind of, nothing that's, points to one thing. Whereas in Norway and the Yukon, almost all of the artifacts that people are finding are related to hunting. People were doing other things up there, but much of what they were doing was pursuing prey in the mountains. Here in the Alps, people were also hunting, but they were using these mountain passes and ice patches more as travel corridors. And some of these ice and glaciers in these mountain passes were used more during the winter time. They were easier to pass, especially if it was a glacier, because then all the crevasses were filled in and you weren't, at risk of falling through one of them. That's a terrible picture of the Alps. I'm going to skip that. And so, where else in the world might we expect to find ice patch artifacts? And if you look at, where perennial ice is in the world, you see that there's a lot of potential in the Andes, tons, a lot of potential in Asia, a lot of potential in New Zealand, and there's even a few bits in Africa. And I would expect that if people were looking in these places, they would find ice patch artifacts. And so, in my book, I wanted to tell a larger story of not just like what was found and how people were using the mountains, but the relationship between humans and these glaciers and the mountain landscapes through time. So ice patches aren't as prevalent in the Andes as they are in other places that I've spoken about. It's really a landscape largely of glaciers. And while they are starting to melt, because they are so high, they haven't been as affected as the Rockies or the Alps or other mountain ranges at lower elevations. And so these uses, people haven't really, although archaeologists have been looking to the mountains, you might have heard about the 3 children who were found on a high mountain in the Andes years ago. And that's not really ice patch archaeology, but it gives you an idea of that, people were using these mountains in the past. And one of the ways that they have used the mountains is through spiritual pilgrimages, which doesn't really leave a tangible trail of your evidence if you're going there for spiritual purposes, although I would expect that people would still be losing things. So there's an annual festival in Peru every year, where various Quechua-speaking tribes gather together. It's called the God of the Snow Star, Coyariti, and it celebrates the return of the Pleiades constellation in the southern sky after several months hiatus. So when that constellation isn't visible, the world is seen to be a very dangerous place. And the purpose really of the spiritual pilgrimage is to pay homage to the glaciers. There isn't much rainfall in the Andes. It's a very dry landscape. And they rely on meltwater from these glaciers for almost all of their water. So this is a picture of where that pilgrimage takes place in the Andes. It's about 17,000 feet in elevation. It is, I had the opportunity to go and visit and watch this pilgrimage. It's a really remarkable experience and very difficult to do anything that high. There's a lack of oxygen. It's just a difficult landscape. But here's a couple of photographs of pilgrims coming down off the mountain. And there were children, little babies that would be taken up there. It's a picture of the grounds. It's become such a thing that they have actually built a church. They have built several, they have like a little market there, and just the people camping all over the place, and it's just a 3-day festival in June. So like a lot of cultures around the world, Western colonialism has kind of taken its toll, and you can see the cross here. And so they call it a syncretic pilgrimage between Catholicism and the Quechua religion. But the Quechua are really taking back their pilgrimage from the Catholics and making it their own and remaking it. And there's still going to be Catholic elements, I think, because it's such a highly Catholic, a lot of Catholics there. But they're getting back to their roots of what this pilgrimage really means, with paying homage to the glaciers and worshiping the stars. So I also did some research about some innovations that people are doing to kind of mitigate what's happening in the mountains and how fast the ice is melting. And there is an ancient practice in Pakistan where people have been growing glaciers for centuries, and it goes back, we don't know how far. This is just through talking to people. This person did his master's thesis on it, and what it is they actually grow their own glaciers. And so in their spiritual ideology, 12 men go in search of what they think is a female glacier, which is the beautiful white classic glacier. That is considered to be the life-giving glacier. And 12 different men will go in search of a male glacier, and the male glaciers are the ones that are more dirty and have rock debris on it and that aren't considered the life-giving force. And each person will take a chunk of the glacier with them in a basket, and they meet at a place that they've predetermined is a good place to grow a glacier, and they bury it in the ground, they merge those, they marry the pieces of ice, and they bury it in sawdust and rock, and they cover it over, and as time goes on, it is said that this glacier actually grows into a fully functioning glacier. And so people that they have talked to, that this master's thesis student has talked to there, say yes, this actually works. Now they have a glacier above their village. I think, yeah. I don't, I'm a little bit skeptical that there is actually a glacier there, but yeah, I mean, I think it's possible that, you know, with burying the ice and keeping it cold, and then as water melts down from the top of the mountain, that it will grow, and it will accumulate more of that water and grow to become at least some small body of ice. And there's evidence to support that this actually does occur, because on the opposite side, in India, in the Himalayas, an engineer heard about this, and he decided, I'm going to try to grow my own glacier. And so what he did is pictured on this right-hand side. Above a wild glacier or a natural glacier, he would carve out this meltwater stream here where a lot of the water would run down, and he would create these terraces that would go across the slope. And he made these rock walls to be a bit leaky, so that as the water came down during the summer, and actually the Himalayan glaciers melt all year round a little bit because of solar radiation and how sunny it is there all the time. And some of that meltwater would come and fill these holes and then drain down through these leaky terraces and form a glacier above the village. And so what would happen is that glacier, because it was lower down the mountain than the wild glacier higher up, would melt sooner. And so they were able to get water earlier in the season for growing their crops when they needed it. And then as that glacier disappeared, the wild glacier would start giving them water later in the season and providing enough water to get them to the harvest. But it's a little bit expensive to build one of these things, and it takes a lot of labor to do that. Here's another illustration of what that artificial glacier looks like. So one of this engineer's prodigies, Sana Wangchuck, has took a little bit of a spin on this ice glacier thing and started creating what he calls ice stupas after the Buddhist temples. And what this is he buried a pipe below the ground so that it doesn't freeze, and it collects meltwater from the glacier, and through pressure it spews water up through the pipe. And as it rains down, they have put all of these willows and natural materials on this wire structure to catch this water as it comes down. And it makes these beautiful towers of ice that are not only gorgeous, but they're practical, and they can make them right in a village. So they grow quite large, and they provide water to local residents that might not otherwise have a glacier directly in, for meltwater during the for harvesting, for any of their daily needs. But while these are really amazing, they're kind of band-aids. They're short-term solutions to a really long-term problem. And I think we as a species are, we're relatively short-term thinkers, I think, because for most of our human history, that was our primary focus. We focused on the present and the near future to ensure our survival. We were thinking seasonally and maybe yearly, not in terms of decades or hundreds of years in the future. So it's really hard to think about our future and visualize it, especially if you think you're not going to be in it. So with climate change, it really does feel like it's a problem for the future, but in reality, it's here now. I think we can all see that. We hear the news and we see it with our own eyes. And still, we have a hard time seeing the bigger picture. So we know what we need to do. We know we need to live more sustainably, and we know that we need to draw down carbon. The science is in, and it's been in for decades. Ice patch archaeologists do not have, the luxury of time to go and find these artifacts before they disappear, and neither do we. So looking at climate change through the lens of archaeology, I think, is one way we can help connect ourselves to our past and think about our future, and a future that possibly will not contain any ice at all. And I hope that's not true. But yeah, so I think it helps us, teaches us how to become good ancestors. Thank you.
Thank you for such a great presentation. That was very insightful and informative. We have a couple minutes for a couple quick questions to make sure we have enough time for everyone to meet you afterwards. So if anyone has a question, please feel free to raise your hand. Oh.
She's coming.
I'm coming. All right, you just speak in.
I think you said that we're at the end of an ice age. Could you elaborate on how long it's been? And I think we kind of know what the gaps are between each ice age. Is that correct?
Yes, we do. Scientists have mapped out the ice ages throughout most of the world's history, and right now, so we think of the last ice ages having ended around 13,000 years ago, but it's really just like a blip within the larger ice age. So we've been going up and down with these climate, stadials and interstadials, so these ice ages and these warmer periods. And so we are in just a warmer period right now of the larger ice age. And really, when you look at human culture, we've really boomed since about 13,000 years ago. So as the climate got warmer, we were able to grow, foods in many, many different places and travel more easily around the planet. So we are in an ice age technically right now. It just happens to be a warmer period within the last ice age.
Looks like we have one in the back. Two in the back.
Hello. I wondered, is it true that people arrived in North America across the Bering Strait? And has research been done up there? Are there artifacts in that area?
Yeah, lots. Yeah. So it's underwater now, so there's probably lots. And I think a lot of that is like the standard thinking, is that people came across the Bering Strait when sea levels were much lower, and there was just more land area, and that land area being more prevalent around the world during the last ice ages, because so much of the water was tied up in ice, helped us really move around the world. But there's also there's lots of different theories, but another one is that we took a coastal route, and we were actually in boats along the west coast. And so with higher sea levels now, a lot of that archaeology is probably underwater. And so just really hard to get to and difficult to get to.
Yeah, I don't know that I need this, but what about Siberia? Have we not seen some examples of melt up there?
Oh, yeah.
Some interesting discoveries?
For sure, yeah. Well, and a lot of the things that have come out of Siberia are ice age mammals, and sort of bioarchaeology. Not too long ago, maybe a decade ago, there was actually an outbreak of anthrax in that region because of the melting ice, and it really got a lot of people sick, and unfortunately a child died of anthrax. And so some scientists think that the next pandemic may come from the ice, because we just don't know what's buried there. I think that's not really a big problem considering all our other problems today. That's something to worry about, but it's kind of an interesting thing to think about, because they also took some ice samples from the Tibetan plateau, some scientists did, and they found hundreds of viruses in the ice that they were able to reanimate and bring back, and some of them were unknown to science.
But why anthrax?
I don't know. Well, yeah. Frozen, it can last forever. And, ice is such a good preservative. So bacteria and viruses can really survive in the ice as long as it stays frozen. And then get reanimated when it melts.
Do ice packet archaeologists actually dig, or do they just wait until it melts?
They wait until it melts. And so they have to go back to the same ice patch every single year. And so it's not like a traditional archaeologist where they're digging in the dirt. They've got this area and they can kind of cover it up and maybe take some time off. No, they have to go back during the, in the northern hemisphere, like late summer, July, August, September, to monitor these ice patches. And they have to go back every single year, otherwise they don't know what they might have missed.
And do the packets, ice packets themselves expand and contract?
They do, yeah, yeah. And that's why they go at the end of summer, because that's when they're gonna be at their smallest extent. Yeah.
Okay, well, if we don't have any more questions, thank you so much for joining us.